Hello. In in today's in this particular unit, we're going to be talking about various shapes. So especially we're going to talk about prisms. We're going to talk about cylinders and shapes of that nature. And we're going to be covering things like finding the surface area for them and finding the volume for them as well. So before we get in, so we call this measuring prisms and cylinders, so surface area and volume. Now it's important for us to completely understand each of these two and also to know the differences between them. And so once we talk about that, we're going to start moving into examples and we're going to talk about different examples as well. So surface area is a measure or the measurement of the exterior of a particular shape. So any shape that you're talking about, the measurement of the exterior, or basically the area of the exterior of that particular shape. So for example, if you're talking about a prism, like how we have a prism here, and they're asking you for the surface area, so that means you have to figure out the measurement of the entire exterior of that shape. So that's usually what you do when it comes to area. And so for volume, when they're asking about volume, they're talking about how much space a particular shape contains. So for example, if you have a particular shape, like say a cylinder, and they're asking you for the volume, they're asking for how much space you can find in that cylinder, basically. Then another thing that we want to talk about here is whenever they're talking about surface area, let's say you're doing your unit in centimeters, you have to always do squared. So for example, centimeter squared, meter squared, and so on and so forth. But then when they're talking about the volume, you have to do cubed. Okay, so now the reason why we're doing squared here is because usually when you're doing surface area, you're finding various areas, for that particular shape, and then you're putting all the shapes, all the areas together, So because you're going with area, because you're dealing with area, you have to do squared. So for example, if you're looking at a rectangle, the area is length times width. So you're dealing with two items, so you're squaring because square means two. But now when you're doing cubed, for example, in this case, you're dealing with three different items. So you're usually dealing with length and width and height. So you're dealing with three different items: length, width, height. So cubed. Because in math, anywhere you're cubing, that means 3 times. So anywhere you're squaring, that means 2 times. So that's another very important thing that we need to know here. Then another thing I want to say about this particular unit is that please know your formulas very well. Because majority of the questions you'll be dealing with in this unit has to do with formulas, so you have to know all your formulas. Or depending on the teacher that you're working with, I know in some schools, whenever you want to have a test, your teacher may provide you with some formulas. So just make sure you're always checking with your teachers so that if you're not being provided the formulas, please make sure you memorize the formulas for that. So this is now the first example here. The first example says that find the surface area of this right rectangular prism. So the shape we have here is a right rectangular prism. Now it makes sense that this is a rectangular one because we can see a rectangle here and we can see a rectangle here. Now this is important because later on we're going to talk about triangular prisms. So this particular one is a rectangular prism. So we need to understand rectangles and go from there. Now, because the question is asking us to find the surface area, if you remember earlier on, we said when you're dealing with surface areas, you're dealing with area. So that means that we have to figure out the area of every single side of the rectangular prism and then add them all together. So that's what we're doing here. So let's get started. So if we picture this in 3 dimensions, we're going to see now we're going to have 6 different sides. So we have this side and the one opposite it. We have this side and the one opposite it right there. We have this face or side and the one underneath. So making 6. So basically, each side that we're seeing here is duplicated. So we have an identical one of that, basically. So I'm going to do something like this. So we're going to have 2 of A, this one and the one on the other side. We're going to have 2 of B, and we're going to have 2 of C. So we're going to figure out the area for them, for each of these. We're going to multiply them by 2 or double them because we've got 2 of them. And then we're going to have all 6 sides, and then we're going to add them. So I'm going to start with A. I'm going to say that area of A. Now, the area of a rectangle is length times width. We can see that all these ones are rectangles, and that's why we're calling this a right rectangular prism. So rectangular. So area is length times width. So we've got these and that. So we're going to do 8 times 2 equals 16 centimeters squared. Now let's move on to B. Remember, each face is duplicated. So you have 2 of each face. Area B. Again, all areas here are length times width, so I'm not going to repeat that. So this one is going to be, now we can see that this length is the same as this length, so this is 2 centimeters, and this length here is the same as this length here, and that is 3 centimeters. So this will be 2 times 3 equals 6 centimeters squared. So area of C, so this is C here. Now one of the 2 sides we need is 3 centimeters here, and we need this other side, and this is 8 because this is the same as this length. So 8 times 3. So 8 times 3 is 24 centimeters squared. Now, we're going to double each one, and we're going to add them all together. So, we're going to say that total area, so total surface area is 2 times A, or the area of A, plus 2B plus 2C. So 2 times the area of A plus 2 times the area of B plus 2 times the area of C. So here equals, now 2 times A, so 2 times 16 is 32. 2 times the area of B is 2 times 6, which is 12. Plus 2 times the area of C is 2 times 24, which is 48, equals, now 32 plus 12, actually I'm going to go like this, 12 plus 48 is 60, 60 plus 32 is 92, so this is 92. Now please, let's be very careful with our unit here. because they're asking us for surface area, our unit is going to be centimeters squared. If they are asking us for cube, our unit will be centimeters cubed. So please, let's be very careful there. So our total surface area here is 92 centimeters squared. And I'm just going to check my work here. So A is 8 times 2. B is 2 times 3. C is 3 times 8. So 24, 32, 12, 48. Perfect. So, yeah. So now we're going to move on to the next question. All right. So now we're moving on to triangular prisms. So the first one I will start out with is rectangular prism. But now this one is a triangular prism because we can see a triangle here at the top and we can see a triangle here at the bottom. Unlike in that one that we had the rectangles instead of these triangles. So again, also for what we did there, we're going to do the same thing here. So which is figure out and calculate the area for all the different sides or faces of this prism and then add up all the areas together. Now from here I can see that we have five different faces. We have the top, we have the bottom, the two triangles, those are two. We have this face, then we have this face, and lastly we have this particular face. So we've got a total of five faces here. So I'm going to start. I'm going to do the two triangular faces. I'm just going to call those areas 1 and 2. Now the area of a triangle is half base times height. I'm going to say multiplied by 2 outside. Multiplied by 2 because we've got two of them all together. So if I'm looking here, my height is this little one inside here is 18 and my base is 31. So half 18 31 or half 31 18. Actually, I'm going to start by just writing the formula. So equals 2 times 1 over 2, because 2 times half base times height, 31 18. Now here I can see that the 2's cancel out. So I've got 31 times 18 here. Three 1 times 1 8. I've got 558. Centimeters. Now because I'm doing surface area is going to be squared. Then I move on to area 3. Now I'm going to do this particular face now. So this is a rectangle. And the area for a rectangle is LW, or length times width. And so I'm looking at 40 times 31. So this is 1240. Now area 4. So we've got this one here, this rectangle, and we've got this rectangle. So area 4, because it's a rectangle, is length times width. So I'm looking at 20 and 40. So 20, 40, which is 800. So 20, 40. And I'm looking at this last one. This last one here is 2940. So I call this area 5. So that's 29 times 40. Now this is 40 because this is of equal length to this. So 40, 40. They're parallel to each other. So 29 times 40. $1160. So my total surface area is going to be the addition of all 5 of them together. So total, I'm going to have 558 plus 1240 plus 800 plus 1160. So 558 plus 1240 plus 800 plus 1160. So equals 3758 centimeters squared. So 3758 centimeters squared. So basically, you have 5 different phases. 5 different phases. You're finding the area for each of the 5 phases. Note that these 2 triangles are the same. So I'm just doing 1 and 2 together, multiplied by 2. And then I find area 3, 4, 5. Then I combine them all. Alright. So right now we're moving on. We're moving on to the volume. So over here we are dealing with a right rectangular prism, and we have a question asking us to figure out the volume. And over here we have a triangular prism, and we have this question asking us to figure out the volume of this triangular prism. Now remember, the volume has to do with figuring out or calculating the amount of space the interior of the shape has. So I'm just starting my solution from here. Like we said earlier on, you need to know the appropriate formula for the question that you're dealing with. So the formula for this one is the area of the base times the height. So that's the formula for this one. The area of the base times the height, basically. So, all right. So yeah, I'm just going to start from here. So